Hi folks, this is Shefik. In this video, we are going to talk about lightweight digital signature algorithm, or shortly LightDSA for Python. But before we begin, please like the video and do not forget to subscribe to the channel to stay up to date with the latest videos. Also, your comments are more than welcome. Thank you for your all support in advance. Firstly, LightDSA is a hybrid library supporting various digital signature algorithms such as elliptic curve digital signature algorithm, or shortly ECDSA, Edwards curve digital signature algorithm, or shortly EdDSA, RSA and regular digital signature algorithm, or shortly DSA. In my blog, we already focused on elliptic curve digital signature algorithm in this post. Also, we focused on EdDSA, DSA, and RSA, and we implemented them from scratch. But with LightDSA, you don't have to know the in-depth knowledge about the logic behind all of those algorithms. You can build and run them with a few lines of code. First things first, you need to run pip install LightDSA command in your terminal to install the Python package from Python package index. Thereafter, you will be able to import the library as from LightDSA, then LightDSA. Secondly, I'm going to build a crypto system. Let's call it DSA, and here I'm going to initialize LightDSA object, and as an argument I'm going to set the algorithm name. The supported algorithms in LightDSA are elliptic curve digital signature algorithm, Edwards curve digital signature algorithm, RSA and DSA. In this experiment, let's set the EdDSA. And secondly, for elliptic curve based digital signature algorithms, you can also set form name. Supported forms are Weierstrass, Koblitz, and finally Edwards. If you are using EdDSA, then the default form is Edwards curves. And secondly, you are able to set the specific curve in the input arguments. Let's set the form name to Edwards, and let's set the curve name to the default one is at 25519. To find the supported curves list in the readme of the LightDSA, you should go to elliptic curve forms and predefined curve section, and here see curves page for more details. As you can see, there are hundreds of predefined curves available in LightDSA, and as I mentioned, at 25519 is the default one, but alternatively you can set anything for Edwards listed here. Similarly, for Weierstrass form, these are the supported predefined curves, and finally these are the predefined curves for Koblitz form. For Weierstrass form, the default is SegP256K1. This is being used in the Bitcoin also. And for Koblitz form, the default is K163. Constructing our crypto system is generating the private and public key pair. You can see them as DSA, then access its DSA object, then access its keys. As you can see, this stores both private and public key. Here, private key is going to be used by the signer and public key is going to be used by the verifier. So I'm going to export those keys. DSA.export keys. Let's export the secret first. Thereafter, export the public key. Public.txt and set this is public. This stores the private and public key information into secret.txt and public.txt. So I don't need the DSA anymore because it stores both private and public key, but my experiment requires to use signer and verifier. Let's delete the DSA object. Now I'm going to construct another LightDSA object for signer side. Let's call this signer underscore DSA, and here I'm going to set an additional argument which is key file. This is going to depend on secret key. Thereafter, let's set a message. My message is, let's say, hello world. Then I'm going to sign this message with signer DSA object. Here I'm going to use signer DSA.sign and send message. This is going to be the signature. Let's see what the signature is. As you can see, it's a tuple, and the first item is also tuple. This is the signature format of EdDSA. Now I'm going to build another LightDSA object for verifier side. In this case, this is going to for verifier, and this is going to depend on public.txt. Now verifier side is going to use the verify method, and this is going to expect message as message, and signature as signature. As you can see, this is returning true. This means the signature as valid. What if the base message is changed? Let's try this. Instead of sending message, let's send a different message. Hello Mars, for instance. This is going to raise an error, and it says signature is not valid. This is not signature for hello Mars message. In this video, we constructed an end-to-end pipeline for digital signatures. In the one side, we sign a message with private key, and in another side, we verified the signed message with public key. And in this experiment, we used EdDSA digital signature algorithm, Edwards form, and ED25519 special curve. Alternatively, you can use elliptic curve digital signature algorithm, RSA or DSA in your experiments. All you need to do is to set the algorithm name to one of them. If you do like this video, please like it, and please do not forget to subscribe to the channel. Also, if you make comments, it will help me to reach much more people. I'll be appreciated in that case. Thank you all for watching, and see you next time.